Hello everybody. Now we shall discuss about digital voltmeter. A digital voltmeter is used for the measurement of analog signals. It is a it is a voltage sensitive device. That is the responsible quantity for this measuring instrument is voltage. It measures DC or AC voltage. A digital voltmeter is used for the measurement of analog signals and it is a voltage sensitive device. That is the responsible quantity for this instrument is voltage. Now coming to the block diagram of digital voltmeter. This is attenuator. The voltage to be measured is given to this attenuator. Input voltage is given to this attenuator. ADC. The voltage which is given to this attenuator is input voltage. That input voltage is attenuated by this attenuator and that output voltage is given to this ADC. That is, this attenuator will reduce the amplitude of this input voltage. Next, you're going to have counter. Next, you're going to have readout system. Digital readout system. Okay, input voltage is given to this attenuator, and this will reduce the amplitude of this input voltage, and that voltage will be given to this ADC, and this analog to digital converter will convert analog signal into digital signal. Okay, that is, this will generate digital pulses like this. This will generate pulses. These pulses will be given to this counter, and this counter will counts the number of pulses. Counts the number of pulses. And this here we use decade counter. This will be decade counter. Okay. So here we are going to have a decade counter. This will count from 0 to 9. Okay, so this counter will generate BCD code. If it is counting 0 means this will produce 0000 BCD code. If it is counting one pulse means it will produce 0001. If it is counting two pulses means it produces 0010. Likewise, if it counts 9 pulses, okay, this is 0 clock, 1 clock, 2 clock, 9 clock. Okay, so then 1001. Okay, this is what? This is BCD code. Okay, this ADC will convert analog signal into digital form, digital signal, that is, it is generating pulses like this, digital pulses. Okay, this counter will count the number of pulses. If it is counting 0, if the number of pulses is equal to 0 means it will produce 0000, that is BCD code. It will produce BCD code. If it is counting 1 pulse means 0001. If it is counting 2 pulse means 2 pulses means 0010. If it is counting 9 pulses means 1001. Likewise, it counts from 0 to 9. It counts from 0 to 9 and displays sorry and it generates BCD code. This counter will generate BCD code and counts from 0 to 9. And this BCD code is given to 7447 IC. This BCD code is given to 7447 IC. This 7447 IC will convert BCD code into 7 segment code. That 7 segment code is given to 7 segment display. Okay, you're going to have 7 segment display like this. You're going to have 7 LEDs. 1, 2, 3, 4, 5, 6, 7. 7 LEDs. Okay, this is 7 segment display. depending upon this 7 segment code, this 7 segment display displays decimal number. If BCD code is, suppose if BCD code is 0001, okay, this IC will convert this BCD code into 7 segment code, so that this 7 segment display displays 1. Okay, so this code will glow this LED, this will make this LED glow as well as this LED to display 1. So it displays 1 like this. Remaining LEDs will be turned off. Okay, this 7 segment code will turn on this and this LEDs, both LEDs. So it displays 1 like this. So this is the block diagram of digital voltmeter. After counter, you are going to have 744 IC to convert BCD code into 7 segment code. This counter will count the number of pulses. Here we use dual slope type ADC. Coming to the working of digital voltmeter. Before discussing about working of digital voltmeter, let us discuss about decade counter and 7 segment digit. This is decade counter. QA, QB, QC. Input given to this decade counter is digital signal. Number of pulses given to this digital counter. This will generate BCD code 000 for 0 clock. Okay. This will be 0001. If it is counting 1 pulse means the BCD code will be 0001. If it is counting 2 pulses means 0010. If it is counting 3 pulses means 0011. The BCD code will be 0011. Likewise, if it is counting 9 pulses means 1001. Okay, this is what? This is BCD code. It counts from 0 to 9. Coming to 7 segment display. You're going to have 7 LEDs. This is A, B, C, D, E, F, G. 7 LEDs. A to G. Okay, 7 LEDs. You're going to have 7 LEDs. That is, if you want to display 2, then this decade counter will produce 0010. This code is given to 7447 IC, and this will produce 7 segment code. This 7 segment code is given to this 7 segment display. So it displays 2. It displays 2 by glowing A, B, G, E, D. Okay, so it displays like this: A, B, G, E, and D. So 2 will be displayed. Okay, by turning on A, B, C, E, D, this displays 2 decimal number, and this code will turn off remaining LEDs. Okay, that is, for 0 clock, for 0 clock, for 0 clock, BCD code will be 0000, and QA, QB, sorry, QB, QC, QB, QA. Okay, 0000 BCD code. A, B, C, D, E, F, G. Okay, so to display 0, this will be turned off. Okay, you're going to turn on remaining all LEDs. So it displays 0. It displays 0. 1 clock, code will be 0001. That 7 segment code will glow B and C, and that will turn off remaining LEDs BC. Okay, so it displays like this BC. This code will make B and C glow, remaining LEDs will get turned off. Remaining LEDs will get turned off. So displays 1. Okay, displays 1. Likewise, 9 clock means 1001. For displaying 9, okay, E will get turned off. All LEDs will glow. Okay, if this BCD code is given to this 7447 IC, then this will convert BCD code into 7 segment code. This 7 segment code will LEDs make all LEDs glow except this LED. This will turn off this LED, and this will turn on all LEDs. So it displays 9 like this. It displays 9. Decimal number will be displayed on 7 segment display like this by turning on all LEDs except this LED. So you have decade counter, is QA, QB, QC, QD. You're going to have 7447 IC. It converts BCD code into 7 segment code. 7 segment code. This 7 segment code is given to 7 segment display. Okay, A, B, C, D, E, F, G. Now we'll go for working of digital voltmeter. Working of digital voltmeter. First, you're going to have attenuator. This is attenuator. We're going to have 3 points: point A, point B, and point C. We're going to have switch. This is connected to this. Here this is ADC, analog to digital converter. Here we use dual slope integrating type. Dual slope integrating type ADC. Integrating type ADC. If the switch is thrown to position A, means the voltage range will be 0 to 1 volts. Okay, the range will be 0 to 1 volts. Okay, if this is the range, then the resolution will be 1 millivolt per step. I will come back to this point. For the range of 0 to 1 volts, the resolution will be 1 millivolt per step. Okay, and this will this is DC1, digital counter 1, DC2, DC2, and this is DC3. Three counters are cascaded, connected in series. All three counters are connected in series. Here this is 3-digit DVM because it displays 3 digits, 3 full-digit DVM. It displays 3 full digits. This ADC will convert analog signal into digital signal. This digital signal is given to this DC1. This counts from 0 to 9, again this also counts from 0 to 9, this also counts from 0 to 9, and you're going to have here you're going to have 7447 IC. Here also you're going to have 7447 IC. Here also you're going to have 7447 IC to convert BCD code into 7 segment code. That 7 segment code is given to 7 segment display. So this is least significant bit, and this displays most significant bit. Okay. Input voltage is given to this attenuator. You give some analog signal. Analog signal is given to this attenuator. This is the voltage to be measured is given to this attenuator. Voltage to be measured is given to this attenuator, and it provides the required range. Okay, for this switch is thrown to position A for 0 to 1 volts range. To get 0 to 10 volts range, switch will be thrown to position B. Switch will be thrown to position C in order to get 0 to 100 volts range. Here you're going to have decimal point selector also. You're going to have decimal point selector. Decimal point selector. You're going to have switch. This is A, this is B, and this is C. If the switch is thrown to this is switch. If the switch is thrown to position A means you're going to have point before this digit. If the switch is thrown to position B means you're going to have point before this digit. If the switch is thrown to position C means you're going to have point before this digit. Okay. These two switches are mechanically coupled to each other. On front panel of DVM, you can select the required range. If you want to select this range, that is 0 to 1 volts, switch will be thrown to position A. Okay, by moving that knob on the front panel of DVM, you can get the required range. If that knob is moved to this range, means indirectly the switch will be thrown to position A. As these two switches are coupled mechanically, coupled to each other, if this is thrown to position A means this is also thrown to position A. Both will be in position A. Okay, this is thrown to position A as well as this is also thrown to position A. Okay, to get the required range. Okay, the voltage given to this ADC is V in by N. V in by N. Here N will be in powers of 10. Okay, if the switch is thrown to position A, then the voltage given to this ADC is V in by, this is V in by 10 power of 0. If the switch is thrown to position B means the voltage given to this ADC is V in by 10 to the power of 1. If the switch is thrown to position C means the voltage given to that is ADC is V in by 10 to the power of 2. Okay, 1 by 1. Okay, attenuation factor is 1. Here attenuation factor is 1 by 10. Here attenuation factor is 1 by 100. Okay, so voltage at point B is less than voltage at point A. Voltage at point C is less than voltage at point B or A. Likewise, the voltage will get attenuated. That attenuated voltage will be given to this ADC. If you want to get this range, the switch is thrown to position A. If you want to get this range, then switch will be thrown to position B. Okay, if the switch is thrown to position C means you can get this range. Okay, this V in by N is given to where N is equal to 10 to the power of 0, 10 to the power of 1 and 10 to the power of 2 like this. Okay, this will be in powers of 10. Okay, this converts, this input voltage is given to this attenuator. Attenuated voltage is given to this ADC. This will convert analog voltage into digital form. This will generate number of pulses like this. This digital voltage is given to this DC1 and this DC1 counts from 0 to 10. If the switch is thrown to position A means here also the switch will be thrown to position A. That is, point will be before this. You are going to have point before this digit in order to get this range. Okay, so here number of pulses are produced by this ADC. Number of pulses will be given to this DC1. This DC1 will count from 0 to 9. This will count from 0 to 9. Number of counts by this DC1 will be 10 counts from 0 to 9. Okay, so This displays from 0 to 9. So this DC1 will produce BCD code. That BCD code is given to this 7447 IC, and this will convert BCD code into 7 segment code. That 7 segment code is given to this 7 segment display to display decimal number. Okay, if it is the BCD code is 0000 means this displays 0 by turning on these LEDs except this LED. Likewise, it displays decimal number depending upon the code given to this 7 segment display. Okay, if it counts one pulse means code which is generated by this DC1 is 0001, that is BCD code. That BCD code is given to this 7447 IC, then this converts BCD code into 7 segment code to display 1 like this, and that code will turn on these two LEDs only. That will turn off, that will make remaining LEDs off. That will make these two LEDs on to display 1. Like this it will display from 0 to 9. After counting 9 pulses, this DC2 will start counting overflow pulses. Next you are going to have overflow pulses. First, DC1 will count from 0 to 9. When it comes to 10th pulse, it starts counting from 0 to 9. Okay, so that is DC2 will count overflow pulses of DC1. This will count overflow pulses of DC1. Okay, and this will count from 0 to 9 pulses. After completion of counting 9 pulses, it starts counting. That is, this will count overflow pulses of DC2. Okay, so this counts from this DC1 counts from 0 to 9. This also counts from 0 to 9. Again, this also counts from 0 to 9. Okay, so this will display from 0 to 9. Again, this is also displays from 0 to 9. This also display from 0 to 9. This also displays from 0 to 9. Okay, you're going to have the circuit like this. This is a circuit of DVM. Rollover of 3 full digits. Three 7 segment displays from 000, 001, 002, likewise 010, okay, 019, okay, likewise it displays 999. All 7 segment displays will display 999. Okay, anyhow you're going to have 3 full digits, 3 7 segment displays. Okay, This will display from 0 to 9. Again, this also display from 0 to 9. This also displays from 0. This also displays from 0 to 9. Okay. Likewise, 0 0 0 from 0 0 to 9 9 9. Okay, this will display from 0 to 9. This also displays from 0 to 9. This also displays from 0 to 9, like this. Okay, then the number of counts will be from 0 0 0 to 9 9 9, 0 0 1. Okay, this is first count, first step. Number of steps are number of counts. Okay, likewise from 9 9 9 to 0 0 0, this will be thousandth step. That is, total number of counts will be 1000. Total number of steps is equal to 1000. 1000 steps. 1000 steps are 1000 counts. Okay, number of counts. It counts from 0 to 9 means 10 counts. It counts from 0 to 9 means 10 counts. It counts from 0 to 9 means 10 counts. Total number of counts will be 10 to the power of 3. In general, 10 to the power of n. N is equal to number of full digits. N is equal to number of full digits. Here you are going to have 3 full digits. So this will be 3. 10 to the power of 3. Total number of steps will be 10 to the power of n. Okay. The switch is thrown to position A. The switch is at position A. Okay. The switch is thrown to position A means you are going to have 0 to 1 volts range. If you select this range, the switch will be thrown to position A. Again, here also this switch is thrown to position A only. That is, you are going to have point. This is decimal point selector. Okay, you are going to have point before this digit. Before this digit. Okay, so first you are going to have point. Then first decimal number will be 0 0 0. Okay, here decimal number is 0 0 and 0. Okay, 3 segment display 0 0 0. Next you are going to have point 0 0 1. Next you are going to have point 0 0 2. Okay, likewise 0 0 9. Okay, next you are going to have, after this, 0 1 0. Likewise 0 1 9. Okay, point. Sorry, the last number will be 999. 0.999. Anyhow, if you select this range, V in will be equal to, this voltage will be equal to V in only. V in by 10 to the power of 0 means Directly input voltage is given to this ADC. Okay. Now, what is the resolution? If the switch is thrown to position A, means the range will be 0 to 1 volts. Okay, voltage given to that ADC is V in only. Okay, VADC is V in, 1 into V in. Okay, what is the resolution? Resolution is equal to the minimum voltage that can be detected by this instrument is 0.001 volts. Okay, so this is one step. This is first step. Okay, next you are going to have thousandth step, 0.00, this number to this number. Okay, the resolution will be 0.001 volts per step, means this is 1 millivolt per step is the resolution. Resolution for the range of 0 to 1 volts. For the range of 0 to 1 volts, this is the resolution. Minimum voltage that can be detected by this instrument is, for this range, is 1 millivolt. So 1 millivolt per step is the resolution. Okay, range, you can also find the range if you know the resolution. 1 millivolt per step into number of steps. How many steps we do have in this 3 digit dVm? In this 3-digit dVm, you're going to have 1000 steps. 1000 steps. Then you're going to have 1 volt. The range of this instrument is 1 volt. Okay. Similarly, the switch is thrown to position B. The switch is thrown to, or the switch is at position B. If the switch is at position B, means what is the voltage given to this ADC? The switch is thrown to position B. If you select this range, means the switch will be thrown to position B, as well as this switch also thrown to position B. Okay, so you're going to have point before this digit. Okay, decimal point will come before this digit. Okay, then the voltage given to ADC, okay, VADC is V by 10 to the power of 1, V in by 10 to the power of 1, 1 by 10 into V in, where attenuation factor is 1 by 10. Okay, anyhow, this voltage is nothing but R2 plus R3 by R2 plus R1 plus R3 into V in. Okay, you know, right? Voltage across this will be V into R2 plus R3 by R1 plus R2 plus R3 according to voltage division rule. Okay, so you're going to have 3 full digits. You're going to have point before this digit for selecting the range of 0 to 10 volts. Okay, here the initial voltage is 0.000 and the final voltage is 0.999. Then what is the range of instrument? 0 to 1 volts. What is the range of voltage? 0 to 1 volts. Okay, Here, if the switch is thrown to position B means, here if the switch is thrown to position B means, here also the switch will be thrown to position B, then you're going to have point before this digit, then anyhow this display 0, 0, 0, 0 0.00, 0 0.01, 0 0.02 and so on like this, and so on like this, 9.99. Anyhow this 7 segment displays from 0 to 9. Again this will also display 0 to 9. Again this will also 0 to, okay, 0 to 9, again 0 to 9. Likewise, you're going to have 1000 steps from 0002 to 999. Okay, then what is the range? What is the minimum voltage? Minimum voltage is 0.00. What is the maximum voltage? Maximum voltage is 9.99. Then what is the range? The range is 0 to 10 volts. The voltage range is 0 to 10 volts. Coming to the resolution, anyhow for 3 digit dBm, you're going to have 1000 steps, because 10 to the power of n means 10 to the power of 3 for 3 digit dBm. Okay, here what is the minimum voltage detected by this instrument for this range? 0.01 volts. 0.01 volts. Okay, so 0.01 volts per step is the resolution, which is equal to 10 millivolts. 10 millivolts per step is the resolution for this range, for the voltage range of, for the uh, voltage range of 0 to 10 volts. Okay, you can also get the range if you know this resolution. Okay, the range will be, range is equal to 10 millivolts per step into 1000 steps, then you're going to get 10 volts. This is the range of instrument. The switch is thrown to, the switch is uh, switch is at position C. The switch is at position C. The switch is at position C, means this is the position C. You're going to get 0 to 100 volts range. 0 to 100 volts range. Okay, the voltage given to this is V in by 10 to the power of 2. Okay, if you select this range means indirectly you are closing the switch, I mean indirectly you are throwing the switch to position C. Sorry, if you select this range means the switch is thrown to position C, and here also the switch is thrown to position C. If the switch is thrown to position C means you're going to have decimal point before this digit, okay, then three full digits, decimal point will be before this digit. Okay, that is 00.0, 00.1, likewise 99.9. What is the minimum voltage? minimum voltage 0.0. Minimum voltage, after this you're going to have 0.1. Okay, minimum voltage 0.1. Okay, likewise you're going to get 99.9. That is from 0 to 99.9. The range will be 0 to 100 volts. Okay, so if the switch is thrown to position C means the range will be 0 to 100 volts. Okay, here we have 0 to 100 volts. Okay, now what is the voltage given to ADC? The voltage given to this ADC is V in by N. Here V in by 10 to the power of 2, 1 by 100 into V in, where this is attenuation factor. Attenuation factor. Okay, this is nothing but V in into R3 by R1 plus R2 plus R3, where R3 by R1 plus R2 plus R3 is 1 by 100. Then what will be the resolution? Resolution. What is the minimum voltage detected by this instrument for this range? 0.1 volts per step. Okay, that is 100 millivolts per step. 100 millivolts per step. Okay, this is resolution. The minimum voltage that can be detected by this instrument for this range is 100 millivolts per step. You can also find the range. Range is equal to 100 millivolts per step into 1000 steps. Anyhow, you're going to have 1000 steps. 1000 steps. Okay, then you're going to get 100 volts. The range of this instrument, if the switch is thrown to position C, is 0 to 100 volts. Okay, for the range of 0 to 1 volts, the resolution is 1 millivolt per step. For the range of 0 to 10 volts, the resolution is 10 millivolts per step. The resolution for this range is, for the selected range is 100 millivolts per step. Then what is the resolution of 3-digit dVm? What is the minimum voltage that can be detected by this 3-digit dVm? Okay, that will be 1 by 10 to the power of n. That is 1 by 10 to the power of 3. Okay, which is equal to 0.001. That is 1 millivolts per step. Okay, 1 millivolts per step. The resolution of 3-digit dVm is 1 millivolts per step. The resolution of 3-digit dVm for the range of 0 to 1 volts is also 1 millivolts per step. The resolution of 3-digit dVm for the selected range is 10 millivolts per step. The resolution of 3-digit dVm for this selected range, that is 0 to 100 volts, is 100 millivolts per step. Okay, thank you.